So this question is a 2016 exam one, question 8. Only 17% of students got the 2 marks. So it's a pretty tricky one. Show by differentiation that x to the power of k over k times k log base e of x minus 1 is an antiderivative of x to the k minus 1 log e of x, where k is a positive real number. So firstly, wrap our head around the differentiation that's going on. So this is an antiderivative of this. So what that's saying is if we were to anti-diff this, we would anti-differentiate this thing, we would get that thing. So that must mean the reverse is true. If we were to differentiate this thing here, we would get this thing. So that's our job. Our job is to differentiate this thing. So what we can do is we can see immediately, hopefully, that it's the product of 2 functions. So we're going to use the product rule. And the first thing I'm going to say is u equals x to the k on k, because that's our first function. And v is our second function, is k log base e of x minus 1. U dash is going to be the derivative of this. This is just, if I just rewrite this quickly, u equals 1 on k times x to the power of k. So u dash is equal to, well, k comes down and then you reduce the power by 1. So it's x to the k minus 1. And then v dash is a bit easier to differentiate. We know that the derivative of log base e of x, it's on the formula sheet, is 1 on x. And then we're going to multiply by k. So it's going to be k on x. And the minus 1 goes away because it's got a constant gradient. So there's no change there. When you differentiate a constant, it goes to 0. And so then what we want to do is we want to do the product rule. So let's just remind ourselves, which says if you want to know dy dx, you want to know the derivative, then you're going to take vu dash minus u plus vu dash. I think I said that wrong. U v dash plus v u dash. Okay, so let's do that. So u v dash, that's going to be x to the k on k times v dash times k on x plus vu dash. So that's going to be k log base e of x minus 1. And all of that's going to be multiplied by u dash, which is x to the k minus 1. Okay, and then we've got this thing here. We can see straight away, hopefully, that the k's will cancel out. So we should get x to the k on x plus, all right, we've got to deal with all this stuff inside here. So if we were to expand this out, we would get k x to the k minus 1 times log base e of x minus, and then we multiply this into this negative 1 as well. So it's going to be minus x k to the negative 1. Not k to the negative 1, x to the power of k minus 1. And then, well, these brackets aren't actually doing anything at the moment, so we can just drop them because it's all addition. It's not subtraction, so we don't need to expand any negatives in. And then hopefully we can actually see something really interesting. This part here, this first part, can be written in the following way: x to the k multiplied by x to the power of negative 1. All right, plus k x to the negative 1 x k minus 1 would be better. Is e of x minus x k minus 1. All right. We notice in this first term here that we've got the same base, but different powers, and that's just one of our index laws. So that can just become x to the k minus 1 plus k x to the k minus 1 log base e of x minus x to the k minus 1. All right, and then finally, x to the k minus 1 is a common factor to all of this. So let's take that out the front. X to the k minus 1 is a common factor. So that comes out the front of k log base e of x minus 1. And then we go look at the question, and hopefully we're somewhere near it. Oh, I missed something. I stuffed up here. Let's just erase that. Let's redo this line. When I took x to the k minus 1 out as a factor, that's 1 plus log base e of x, and then minus 1, and there's a k there. And then plus 1 minus 1 cancel out. So what we get is x to the k minus 1 multiplied by k log base e of x. I don't need the square brackets anymore, so it's x to the k minus 1. Put the k there if we like, log base e of x. That looks a bit better. Let's check. We've still got a factor of k in there. So I just had a look at the 2016 exam. The question was transcribed wrong. So this was supposed to be k squared. Whoops. This was supposed to be k squared in the original question, which when you differentiate it, why is that not working? It has to be k squared in the original question, and then when you differentiate, it does give you this. However, I've checked that when the k isn't squared and we do all this working out, that this is the right answer. So that's right for what we did. It's not right in terms of giving us this as the answer, but that's the correct answer for that working out when that's not squared. But if you look at the 2016 exam paper, that k there in the denominator is squared, which when you differentiate it gives you that. So we've answered a slightly different question, but the same skills are needed. So it is what it is.